Welcome to this explainer. Okay, so if you've been trying to keep up with the breakneck pace of AI lately, I bet it feels a bit like trying to build a house while the ground is literally shifting underneath you, right? It's crazy out there. Today, we're focusing on a detailed breakdown of AI industry trends. What we really need right now isn't just another laundry list of new tools. We need a blueprint, a reliable structural map to cut through all the noise, categorize the tech, and figure out who is actually building the future. So let's construct that mental model together.
Honestly, if you're feeling totally lost in the avalanche of AI buzzwords, things like zero-shot prompting, vector embeddings, RAG, autonomous agents, you are definitely not alone. This sheer volume of info dropping every week is completely overwhelming. But here's the good news. Beneath all that jargon, there's actually a highly logical architecture. Once you see how these pieces plug into each other, the whole industry just clicks. It makes perfect sense. And that's exactly what we're going to decode for you today.
Now look at how beautifully this organizes a totally chaotic industry. We're breaking it down into a literal 3x2 grid. Up top, we've got the foundational tech, so LLMs and RAG. In the middle, the frontier of the future, agentic AI and operational AI agents. And down at the bottom, the human element, the builders, the AI engineers versus the machine learning engineers. It's seriously such an efficient way to categorize who's doing what and how this tech scales from raw data all the way up to autonomous systems.
So here is our agenda for today. 1. Foundational tech, which covers LLMs and RAG. 2. The future with agentic AI. 3. The mechanics of AI agents. And 4. The builders, where we compare AI and ML engineers.
All right, Section 1, Foundational Tech, LLMs and RAG.
The crucial takeaway here is that mastering large language models is way beyond just typing questions into a chat box, right? It takes highly specific engineering skills. You've got advanced prompt engineering, like forcing a model to use chain-of-thought reasoning so it actually shows its work step by step, or zero-shot prompting, where it tackles a completely new task without any examples. You also have to know how to efficiently fine-tune these massive brains. Developers use techniques like LoRA and quantized LoRA, or QLoRA, to adapt pre-trained models for specific tasks. And get this, that can drop compute costs from literally millions of dollars down to just a few $100. It's wild. It's all about shaping outputs, managing context, and leveraging attention mechanisms so the model knows exactly which words matter most.
But, even the smartest LLMs have a pretty massive flaw. They don't know what they don't know, and that leads to them just making things up. Enter RAG, or Retrieval Augmented Generation. Think of it like this. If LLMs are the raw, super smart brains processing language, RAG is the external reference library they are absolutely forced to double-check before they open their mouths. By grounding the LLM's response in retrieved verified documents, we ensure accuracy and aggressively squash those infamous AI hallucinations.
So let's trace that retrieval flow. It's essentially a multi-stage pipeline. First, you take these massive documents and apply text chunking. You're just breaking them down into smaller, bite-sized, meaningful pieces. Next, you convert those chunks into numbers. These are your vector embeddings, which magically capture the semantic meaning of the text. Then, when a user asks a question, the system searches a vector database using similarity metrics to grab the most relevant chunks of info. Finally, it dynamically injects those verified facts directly into the LLM's prompt. It is such a brilliant way to give an AI perfect memory and reliable facts on the fly.
Okay, moving on to Section 2, the future, agentic AI.
Guys, we are talking about a massive paradigm shift here. For the longest time, AI was entirely reactive. You give it a static prompt, it gives you a response, and then it just sits there waiting for your next command. Agentic AI completely flips the script. Now, you give the system a high-level goal, and it autonomously figures out the path, the tools, and the exact steps to get there. It is literally the difference between asking for a recipe and telling a chef, hey, go cook me dinner.
And this design philosophy is just fascinating. It allows for complex task splitting and planning. These agents actually have long-term and episodic memory, so they remember what happened in your previous chats. But the coolest part? Role-driven system design and multi-agent decision-making. Imagine spinning up one agent with a developer persona who writes code, and a second agent with a QA persona who tests it. They talk to each other, they debate, and they use feedback cycles to reflect on and fix their own mistakes before ever handing the final product to you. Like, how cool is that?
Which brings us to Section 3, the mechanics of AI agents.
We really need to distinguish these two concepts because, honestly, they get conflated all the time. Agentic AI is the theoretical framework. It's the philosophy of how the system thinks, reasons, and coordinates. AI agents, on the other hand, represent the operational reality.
This is all about the nuts and bolts of execution, system stability, and making sure the thing doesn't just crash the second it hits a network drop. It's essentially the difference between drawing up the architectural blueprint and actually pouring the concrete.
Building resilient AI agents means you have to prepare for the absolute worst. You're managing secure tool registries so the agent only touches authorized APIs. You're building robust retry systems, because let's face it, when your agent queries a database, the API might time out. The agent needs to handle that gracefully without blowing up the whole task. And crucially, this involves human-in-the-loop, or HITL, checkpoints. If an agent is about to, say, delete a core database or accidentally email 1,000 customers a cat meme, you've got mechanics in place for it to pause, ping you, and ask for explicit human approval before doing the deed.
All right, our final stop, Section 4, the builders, AI versus ML engineers.
This side-by-side comparison perfectly illustrates the fork in the road for modern engineering. On one side, we have the ML engineer, on the other, the AI engineer. ML engineers are your foundational scientists. They are deep in the data and the raw underlying math of the models themselves, using heavy-duty tools like PyTorch. AI engineers, however, are the software specialists. They're the ones actually wiring those pre-trained models into consumer-facing applications using serverless APIs and prompt chaining.
To get a little more specific, the ML engineer does the heavy lifting of data prep and feature engineering, and they aren't just messing with large language models. They use traditional models too, like support vector machines and decision trees for structured data. Their whole world is governed by intense mathematical metrics. They're testing models against F1 scores and ROCAU metrics, which, if you don't know, are basically highly rigorous scorecards to prevent the models from overfitting. They run these continuous loops of hyperparameter fine-tuning and track hundreds of massive training experiments.
Conversely, your AI engineer is operating strictly at the application layer. They are stitching props, tools, and local memory databases together to build these seamless workflows. Rather than training huge models from scratch, they just consume them via cloud-hosted serverless APIs. Their day-to-day is all about speed and cost optimization. Minimizing the time it takes to get that very first token back to the user while keeping those API bills low. They're also on the front lines of security, building out back-end RAG pipelines and actively defending the system against some pretty sophisticated prompt injection attacks.
So, by breaking down this 3x2 grid, that once overwhelming AI landscape becomes a completely logical system. You've got LLMs and RAG forming your knowledge and reasoning baseline. You have agentic AI and AI agents pushing us toward true autonomous, self-correcting systems. And you have ML engineers and AI engineers providing the highly specialized talent needed at both the foundational and application levels. It's no longer just a chaotic cloud of buzzwords. It is a fully decoded structural blueprint of the industry.
I want to leave you with this one question to think about. Now that you actually have the blueprint, where do you fit into this new AI ecosystem? Whether you're a developer trying to pick a specialty, a leader planning your next product, or honestly just an enthusiast wanting to stay informed, use this map to guide your next moves. This tech is going to keep moving at warp speed, for sure, but with this framework in your head, you'll always know exactly where you stand. So ask yourself, are you going to be the one pouring the concrete or drawing the blueprints? Thanks so much for joining me on this explainer, and keep building.